Mobile, Alabama. On the pier of the state docks, the Star Eviva, a 40,000-ton cargo ship from Norway, is being unloaded. On board, there are 5 mill housings. They're needed for the construction of the hot strip mill of the most modern steel mill in the world. ThyssenKrupp is building this massive project in Calvert, which is 70 kilometers away, costing approximately 4.5 billion euros, starting right from scratch on virgin land. Hilchenbach, Germany. The company SMS CMAG is completing the installation engineering of the future steel mill here. The mill housings will be the backbone of the future production line. Later in the steel production, their accuracy will be an important factor. It takes nearly 9 months until the mill housings can be delivered to the USA. During this time, the oversized casting is made into a precision component. Large portable molding cutters cut off layer by layer from the casting, accurate right down to the millimeter. A computer-controlled process with a worldwide unprecedented precision. The precision of the mill housing is transferred to the precision of the rolling process, which is then further transferred to the final precision of the rolled product. Back at the port of Mobile. Every mill housing weighs approximately 140 tons. The biggest port crane in Mobile can only lift up to 95 tons. For this reason, a mobile crane with 1,000 tons lifting capacity is needed to unload the mill housing from the ship. It's the only crane within a radius of 400 kilometers which can lift this load. The plan is to temporarily store the mill housings in a circle around the crane on the pier and then to reload them onto transport barges. Stacking would be easier, however, that is prohibited. Then, 280 tons would be placed on the pier, and that is clearly too much. There would theoretically be 280 tons on one small area here directly by the pier, but the port has declined this. It's expected that we spread out the weight further. There are calculations regarding what a pier can take, and we have to comply with the guidelines given by the port. It wouldn't be very nice if we went ahead and did it anyway. The first shock for the team of project leader Jens Morken came shortly after the start of the unloading process. Suddenly the crane's not rotating. A problem with the oil cooler? The time schedule is already obsolete. As far as money is concerned, Jens Morken stays calm. The shipping company basically has the responsibility for the reloading. That means we're not affected by this in the first place. Where we may have a problem is with our barges. With the tugboat, we may have demurrage on that. We'll have to see what happens. After 2 hours of repairs, the process goes on, albeit not at full speed. The crane company is improvising. Jens Morken sighs with relief. I would rather it take a little longer than me having to hear something like, "So, that's it, come back again next week." Despite good weather, work comes to a surprising stop at 5 o'clock in the afternoon. One mill housing is still in the ship, and it'll stay there. Jens Morken remains calm. Because of the delays this morning, it was difficult to predict when we would be finished and when we would be able to reload. Furthermore, a crew was not appointed for this evening that would hook off on the barge. Off the record, it said that the morning crew is always better than the afternoon crew. The next morning, mill housing by mill housing is loaded onto the barge. And that's easier said than done. We're not able to put the pieces on the center line because of the cargo weight and the size of the barge. That means we have to load them off the center line so that it fits within the outreach of the crane. Now the barge will be rotated and brought into position so that the crane can reach the barge. Around noon, the last mill stand is secured under the barge. Now things can get moving. Yet Captain Aaron Jimison knows that there are risks.
Well, the challenge is leaving this late in the day puts you into traveling at night, which we have radars and we have all the proper electronic equipment to do that. And the fog, as long as we don't experience any fog and get hung up, then we shouldn't have any problems. The river level's down and is good. The traveling time should be good. And the only dangers would be right now would be fog and maybe logs coming down, but you know, that's just part of the river.
Both ships have to go approximately 70 kilometers upstream until they have reached their destination. If everything goes according to plan, it'll take 12 hours. From now on, from the pier onwards, the barges are going to travel north on the Mobile River. then continuing on the Tombigbee River. From this point on, the route goes through swamplands and primeval forest vegetation. The railroad bridge near Satsuma is the last waypoint before the convoy reaches the end of the journey. Unloading cannot be done directly at the job site. There's an unloading dock at the Thyssen facility here that we cannot use. It's not ready yet, so we had to find an alternative. And that is only 1 kilometer away as the crow flies from the job site. The site is technically ideal. We only have to fight with the different water levels. In January we had a lot of water, by February somewhat less, and today we have very little water. We're expecting the water level to continue to decrease. The next morning, the first barge is at the pier. However, there is no talk about unloading. The Tombigbee River is causing the expected difficulties. We're putting more ballast water into the back of the barge at this time so that the barge rises higher out of the water in front so we can push it further onto the beach. Then it'll be fastened and we lay our mats to prevent us from sinking into the mud. I assume that we'll roll off the first piece in 2 hours. The crew goes to work in a routine fashion. However, things don't go the way they should. We placed the barge on top of the sandbank, and obviously the side was not sturdy enough, so the point broke off and the barge broke free. We're glad this happened without cargo. Basically, what we had already assumed yesterday has now occurred, meaning that we have to now dig a bigger bed for the barge to lay onto safely, and that's now being put into action. But this also doesn't happen as originally planned. Meanwhile, the crew has lost 1 day's time, and the water of the Tombigbee continues to sink. Obviously, the barge can't make it over a sandbank. We'll try one last time, and if it still doesn't work, we need to get in a backhoe with a longer arm. It's still a fight against time because the water level is sinking 4 centimeters per hour. Late into the night, 2 excavators dig a provisional bed. The next morning, the first barge is tightly lashed to the landing area. Charlie Brown and his team have worked throughout the night.
Last night after you all left, we continued working on the grading, getting the proper depth for the barge, moved it into place, secured it down, made sure that it set down firmly on the soil underneath it, so we could prepare to start offloading this morning.
Now, only the ramps to the barge are missing. The ramps still need to be welded onto the barges, or else the roll-off operation couldn't be executed safely. There's a great deal of pressure on the ramp from the weight of the vehicle and from the weight of the mill housing and the traction. If we didn't place any stoppers there, the wheels would basically shift the ramp directly onto the barge. With a special vehicle, the so-called SPMT, the mill housings will be driven off the barge. It's unclear if the SPMT can handle the downward slope between the waterside and the barge. Now, the first critical phase begins for the team. We're technically limited in respect to the vehicle's hydraulic lifting capacity. It can lift up to a maximum of 1.80 meters, that's 5 feet 9 inches. If this had been too steep, we would have had to get out the excavator again in order to level it out somewhat. The stands for the mill housing have varying heights so that the SPMT can fit underneath them. This way, the crew hopes to level out the difference between the waterside and the barge. Still, getting the transport vehicle underneath the first mill housing is precision work. Made it. Jens Morken breathes a sigh of relief. As you can see, we're still pretty steep. If we hadn't used a higher setting, we wouldn't have been able to get the vehicle placed underneath the cargo. The barge can't swing or break loose when the first 140-ton mill housing is driven off the barge. That's why approximately 300,000 liters of water run into the ballast tanks and the barge is grounded. The remote-controlled SPMT starts moving. the weight of the mill housings is distributed among 12 individually controlled axles. However, after only a few meters, it stops. The transport crew tries to activate some individual drive axles to distribute more weight, but nothing works. The rise is too steep after all. We just tried to get up without further help, but that doesn't seem to work because the wheels are spinning. So now we're preparing the excavator so that it can help pull out the vehicle. With combined forces, the SPMT is successfully pulled up. Despite a powerful drivetrain of 530 horsepower, the transporter wouldn't have been able to make it up the incline on its own. The rest is a piece of cake. The SPMT has to continue driving roughly 500 meters, and then the mill housing will be temporarily parked on prearranged stands. The problems keep getting worse. The water level is still decreasing. For this reason, the incline to the water side gets steeper, and the second mill housing still has to be brought on land. Meanwhile, the barge has dug itself so deep into the mud that we have a different angle of approach compared to the one we had this morning. Another fact is that there are now 140 tons missing in the rear, and we're trying to get the ramp a little bit more even and hope to get it through this time.
Die Rampe etwas gerader zu setzen und hoffen, dass wir das diesmal hinbekommen.
The next attempt is more successful. This time, the SPMT manages to bring the second mill housing on land with more speed. At first, it got stuck halfway through, but then the crew thought of a few tricks, which got things rolling again. Because of the steep slope, we didn't have enough weight on the drive axle. This vehicle here has 4 drive axles. We had to let off some pressure from the other 8 in order to get more pressure on the drive axles, and then made it up with ease. From now on, everything works out nicely. The SPMT, loaded with the mill housing, rolls off the barge without problems. With all this stress, the question remains, why not transport the pieces over land like you can in Germany? Of course, there are also weight limitations in Germany, but they're somewhat more generous than they are here in the US. Here, there are older bridges, older infrastructures, so the aim is to transport as much weight as possible on the waterways, which is here definitely the case. At the moment, 82 tons is the maximum limit we're allowed to transport on the road. Day 4. The first mill housing is on its way to the job site, and the last 2 mill housings will be unloaded at the same time. The transport continues on public roads for about 1.5 kilometers. Then it passes the provisional entrance gate of the ThyssenKrupp job site. For the last 200 meters, we go across the job site to the storage area by the structural work of the hot strip mill. This is the end of a nerve-wracking week for Jens Morten. Yes, we've had a very interesting week. Mother Nature, technology, and machines have caused several difficulties for us. But it's clear to see that good people can offer good solutions to problems caused by technology, machines, or Mother Nature.
Maschinen oder Mutter Natur.